Welcome back. Let's talk about coordinate systems. Now the next assignment in AutoCAD uses a lot of numerical entry for drawing. Now there are easier ways to draw, and we will be of course using the easier ways, but this is a good exercise in just to build proficiency in AutoCAD. So before we get into the assignment, it's good to talk about a little bit of theory. So that's coordinate systems. So there's 4 coordinate systems that we're interested in. There's absolute rectangular, relative rectangular, absolute polar, and relative polar. So for absolute rectangular, you have a coordinate system. You have the XY coordinate system. Cartesian plane, really. And this is 0, 0. And you've got Y going up like this, and X going this way. So if you were given a series of points, like let's say 0, 0 would be the origin, then like 1, 1, you just plot those points. So like 2, 3 would be 2 over and 3 up, and like 3, 2, 3, 2 would be 3 over and 2 up. So this was point A, this was point B, this was point C, and this is point D. So let's see, A, B, C, D. So that's basically it. It's just plotting. Okay, relative polar is similar, except each point given in the sequence is relative to the point before it. Okay, 2, 3, 4, 5. So let's say you had the sequence. The first point A was 1, 1. So you just you'd start relative to the origin, really, so you'd go here on the first point. But then let's say B was 2, 1. So this means go over 2 and then up 1 relative to the previous point. So B would be here, okay? And then let's C was, say, like 2, 1 again. So you'd go over 2 and then up 1. So C would be here. And that's D. Let's go backwards. Say minus 1, minus 1. You'd go down, or you'd go backwards 1 and then down 1. So D would be here. Okay, so each point is relative to the previous point in a relative rectangular system. Okay, now we have absolute polar. And in absolute polar, you're given a vector, basically, which is a vector is something that has a length and an angle. So it's length comma angle. You're given these two numbers, length comma angle. So let's say you had you got to start somewhere, but let's say you start at the origin, I guess. But then you went 1 comma 0. So it's length comma angle, and absolute polar is what AutoCAD uses for its reference angles. They're always given in absolute polar. So this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And so basically you're increasing in this direction. And 0 is straight out to the right. So let's say we start at the origin and then we go a length of 1 and an angle 0. So we're going to go out this way. We're going to go to 1. I'm going to put some numbers on there, although you don't need them beyond this. Then let's say now we're going to go 2 with an angle of 45. So we'd go a length of 2 and an angle of 45. So we'd go out to here. Then let's go a length of 3 and an angle of 90. And you'd go up 3 and an angle of 90. And let's go back. Oh, wait a minute. I'm doing relative polar here. Yeah. Whoops. Sorry about that. This is relative polar now. It's a little tricky because the way that you enter angles in AutoCAD is always absolute, but the way you interpret like a series of angles, you could interpret 2 different ways. So I think that's a little confusing. Hopefully that'll become clear when you're doing the homework, and let me try and clear that up a little bit now. But anyway, let's do one more angle. So let's do 1 and 180. So I'd go back 1. I go a length of 1 with 180 direction that way. Okay, so this was relative. Let's do absolute. You'll see how they're kind of similar. So absolute, this is the origin. Let's say I had the same sequence. So you're still going to enter the angles, in an absolute way, but the sequence will be all coming off of the origin. So 1, 0 would be this. This would be A. This was A. This was B. This was C. This was D over here. But now the 245. Here I'll rewrite the same numbers just to be clear. So now we're doing 245. It's like this. This would be B because we're doing absolute now. And then 390 would be this. And then 180 would be this. Origins here. Okay, so they're a little bit the same and they're a little bit different. And they're different in that for relative polar, when you have a sequence, each point starts at the previous point, basically. And for absolute polar, when you have a sequence, each point starts at the origin. That's the difference. They're similar in that the angles are all measured relative to this being 0. This is 0 degrees. Same thing over here, 0 degrees. That they have in common, the way you measure the angles, and then they increase in this direction. That's the same. But it has to do with, the difference between absolute and relative has to do with points being, for relative, points are relative to the previous point, and for absolute, points are referenced from the origin. Okay, that's the deal. So we're going to play around with this. Here's the homework assignment on paper. I'm talking about moving the border, and I'll do that for you, and then talking about some ways to select things, which I've talked about in the previous video, but it's good to talk about it some more. Here's some stuff on snap modes. Read this. I post these things. You'll save yourself and me a lot of trouble. Take the time to read these things. All right, so here's the first drawing. It's this thing. So it's a bunch of absolute coordinates. You're just plotting, like this point here. This is point 1, and it's at absolute 0.25, 0.25. Like it's 0.25 over and 0.25 up. Okay, point 2. This is point 2. It's absolute 725. So it's from 0, 0. Let's say 0, 0 was here. Okay, then it's 7 over and 0.25 up. Okay, this point here is 3. It's 8.5 over and 1 up. Okay, that's absolute. I'll do this in AutoCAD for you. Okay, then I'd like you to do a relative polar exercise. So here we're going to start here, and then you're going to go over 3.5 at an angle of 180 degrees, because this is 180. Because remember, in AutoCAD, this is 0 degrees. Over from a point straight over to the right is 0, and then they increase up this way. 90 being up here, 180 being over here, and 270 being over here. So this was 180, 3.75, 180. Okay, now this one is 2.38, comma 150. So they're giving you this angle. Now this CD is a little bit trickier, because this would be 0 degrees, right? Just straight over would be 0 degrees. But for AutoCAD, we need to enter the angle in absolute, really. So we need this angle right here. And what is that? Well, you got to sort of figure it out. It's a good review of trig and just get you thinking the way you need to think for this material. So let's figure if we had a straight line over here, what would this what would this little angle in here be? If this is 150 up top, this in here must be 30 degrees, right? Because it's 150 plus 30 makes 180. Okay, if you then consider this line, it's just a horizontal line straight out at 0 degrees. That would be parallel to this line down here. So that means this angle in here would also be 30. Okay, then they've given us 75, so the remainder must be 45. So what you have to enter in the CAD system is 1.75, comma 45. Okay? So the sequence basically, for point, we start at 0, 0. Then for point B, to get to point B, you're going to go 3.75, comma 150. No, 180, right? Yeah. Then to get to point C, you're going to go 2.38, comma 150. And then to get to point D, you're going to go 1.75, comma 45. Kind of like that, right? So a little bit of absolute, a little bit of relative, and just a lot of thinking. Now, once again, there are way easier ways to draw stuff than this. But this is important because sometimes you have to do this kind of stuff. And it's a really good way to get familiar with the CAD system. All right, another theory thing is this idea of vector addition. So I have 3 vectors. They're just a length and an angle. You can add them up. So V1 is this thing here. I'll put an arrowhead on it. Starting here, this is the start. If I go a length of 1.5 and an angle of 35, I get this guy. And then V2, let's go a length of 2.5 and an angle of 120, I get this guy. I'll put arrowhead on there. And then if I go a length of 7.5 and an angle of 5 degrees, I get this guy. Okay, the resultant is this dude. Okay, I'll put a big arrowhead on there. This is the sum of these 3 vectors right here. Okay, so this is something you do in some math class along the way, but this is a quick way to do it graphically, all right? So read this and do that, and I'll do it for you. Okay, the last one, here's an application of vector analysis. So here's a wing. So what I've done here is I've shown the pressure forces, the force due to pressure, let's call it that, at various points on the surface of a wing. And this comes up in, this is Bernoulli's principle, comes up somewhere in your physics classes. They'll talk about this. But let's say I've somehow figured out the force on here at all these locations. What's the total force? I mean, ideally the total force should be lifting up, so this thing will fly. So we can add up all of these things. So what I want you to do is just take these guys. Let's put some labels on here. Just take these guys and start drawing them head to tail. So this was A, this was B, C was about that, D was about that, E was about that, F. And then, this is whatever, P, Q, R. They're going to start coming down. They're going to go all the way around, and then when they're done, you should have a resultant vector that goes up like that. Ideally, that means this thing will fly. All right? So that's the theory for this thing. Take your time and read this. I'm going to demonstrate this in CAD. All right? So I'll switch over to that. Okay, I've got my CAD, I've got AutoCAD set up, and I've got the assignment up. Let's do the first assignment. So remember, you go up to this new button, click that. On my desktop, I've previously downloaded this A size inches template file right here. So we'll grab that guy, and that creates a new drawing, all right? And I'll click this zoom extents button and get it centered, and then I'll use the scroll wheel to back out a tiny bit. All right, so over here on the right, I've kind of set up this thing to draw this. I'm not going to draw the whole thing, but I'll draw a little bit for you. So look, the origin, first of all, is right. Oh, the origin is right here. See, we want it kind of more up in here. So let's just move everything else. So I'll draw a box, click this guy, type M, and then enter. Pick a point anywhere, and then go down like that, and just drop it. So basically I've moved the origin to kind of in the middle, or off of the edge of the border. Okay, let's start drawing. So get into this customization thing and set your stuff up so that it looks like this. Make sure you have coordinates on it, because that's what you need to look at. And then down in here where I'm mousing, this is the coordinates window. Right now it's in absolute rectangular X, Y, and Z. Okay, we're not going to use Z in AutoCAD, but just X and Y. Now look, if you click it once, nothing happens. Sometimes in different modes, when you click it, it'll change to some kind of polar. So just watch that. Just check that it's in. It looks like it's in rectangular. If it were polar, you'd see a little angle symbol in there. Anyway, you're going to be referring to this. You need to be referring to this coordinate system while you're drawing this thing. Okay, let's go back up in here. Escape a couple times to make sure I'm at the beginning. Type L. Enter. So I'm in a line command. I could key in the coordinates right now. I could. You could do that, but I kind of want you to move the mouse around. You know, well, do what you want. But anyway, see it says 0.25, 0.25. That's the first point. I'll click. Then over here in the document, the next point I need is absolute 725. So I want absolute now. So down in here at the coordinates, that's what I was talking about before. This is somehow switched to polar. Click it. Okay, now it's rectangular. Okay. Now there's numbers in the line command, and there's numbers down at the coordinates. They're different. You want the numbers down in the coordinates because these are the absolute coordinates. The numbers in the line command are relative. All right? So that's one of the points of this assignment. So I'm going to find point 725, which is over yonder somewhere. There it is. So I don't want to move the mouse, but look down at the bottom of the window in the coordinates. You see 7, 0.25, right? So that's absolute 725. That's what we want. We don't want to use the numbers that are on the line command. Those are relative. Okay? So click that. Next point I want is 8.51. I'm going to use the scroll wheel to move around a little. I want 8.51. So 1 would be around there. There it is. Okay, so once again, I don't want to move the mouse, but look down at the coordinate box. You see 8.51. And then in the line command, you see some other numbers which are relative. Those, don't look at those. Okay, that's that point. Then we go up to absolute 8.5, 2.25, which is what? Here. Once again, look down at the bottom of the AutoCAD window in the what they call the status bar. There's a little coordinate box, 8.5, 2.25. Okay, keep on plotting like that. And let me do just 2 more. So I want 7 3s here, and then I want to go. I think it's there, right? 8.5, 3.75. So up here. All right, that. Okay, go around like that until it looks like this thing over here. Okay, it's extremely tedious. There are faster ways, and we will learn the faster ways, but this is still a very good exercise for just getting comfortable with coordinate systems in general and in AutoCAD. All right, last thing, you see there's a outside kind of perimeter on this, and then inside there's 3 little shapes. There's a rectangle, a triangle, and a trapezoid. That's these other blocks right here, right? So this right here, this section of numbers right in here is the that's the triangle, I think. And then this other section is, one of them is a square, for the rectangle, and the other one's the, the trapezoid. All right, that's drawing 1. Change the name and all of that stuff, and assemble a PDF like shown in the previous video that's posted. Okay, let me do part of this next one. So I'm going to draw a box here and click delete. Okay, let's draw this guy. So L, enter for line command. We'll start just somewhere, doesn't matter where, like right there is probably good. Okay, now you could key in the numbers using the line command, because that's kind of the default entry mode for the line. By the way, if you don't have these numbers, it's because you don't have dynamic input on, right? And if you don't have a button for dynamic input, it's because you didn't configure, you didn't do this customization thing. You didn't turn on this dynamic input. The check mark here gives you a button down here. That's all it does, is it makes the button visible. And you still got to click on the button. You see, now I've turned off dynamic input, and you can turn it back on, right? So once again, look what we got now. We've got 3.54, that's the length, and then I've got 132.13, that's the angle. So really, it's asking for a polar. It's asking you to enter a line in absolute polar, basically. So I'll key in 3.75 and then press the tab button, and then I want 180. Okay, that's line AB. Okay, now I'm going to do the next line relative to the first line. Okay, but I still need to key in the angle with absolute polar coordinates, and it's 2.38, tab 150, enter. Then CD is, we figured out previously in the video that that's 45 degrees, so I want 1.75, tab 45 degrees. And then the next one we could figure out, it's about there. Here, look, when you move the mouse around, the numbers change. I'm guessing by moving the mouse that it's about there. It looks like it's probably 135. So you can do that. You can sort of move the mouse and kind of help you do the math. You still should do the math. And let's do the math. So what if I went straight out that way? That's 45. And it's telling me in this diagram over here on the right that there's 90 degrees in there. So if I add another 90 degrees, 45 plus 90 is 135. So that's what it is. 2.19, tab 135, enter, like that. So cruise around that way. So let's do one more. 3.62, tab, I think this is going to be 15 degrees, right? Because it's telling me that it's 75 up in here, but if you start at point E and go directly to the right, that would be 0. So the little bitty angle between, straight right and EF it's got to be 15. So that's what I'll key in. 15. Okay, we go on around. Let's say you had to stop or you messed up. Okay, you could click a line and press delete. To start the next line, it's helpful to have endpoint snap on. So that's down in here in the O snaps. Turn off all of these other guys, turn them off, and just make sure you have endpoint snap. Okay, then when you draw a line, escape, it was getting stuck, so I pressed escape. L, enter. Now you get a box, that's endpoint snap. So click, then I'm trying to do 3.62, tab 15 degrees, enter. Okay, go on around like that, get this guy finished. If you run out of room, you could grab everything and move it a little bit. It's not a big deal. All right, there's that. Let me do the vector addition for you, which is, let's do this one right here. Okay, so start start a line command. By the way, I've got this properties window up. Here, let me close it. To get it back, type MO for properties. Somehow MO is properties. And press enter and you get this thing back, which is useful. You'll see in a second. So I'll start the point here, and then the first vector is 1.5 comma 35, right? Second vector is 2.5 tab 120, enter. Third vector, and like I say, I like to move the mouse and kind of guess where the vector is. I just like to do that. And 7.5 tab 5 degrees, enter. Okay, then escape. Now you want to draw a line from the beginning, okay, the beginning where you started out to the end using endpoint snap. Just make sure endpoint snap is on in here, all right? Draw a line from the beginning of that to the end of that. Then if you click the line and you have the properties window open, it'll tell you the vector. It'll tell you the length is 8.309291 and the angle is 26.28 degrees. So just make a label. I'm going to Control C, copy this and paste it here. No, I pasted this by accident. Get rid of that guy. So this guy, just double click it and highlight it, and then V sub R for resultant vector is 8.31 comma 26.28, and you get these numbers from, once again, by clicking the line, and then in the properties window here, which you type MO to get up, the properties window, it tells you down here the length and the angle. Okay, so so there's one more vector in the drawing. I'll let you guys do that. It's the same thing. Then let me do this wing, a little bit of the wing, not much, because it takes a long time. And I'm the teacher, I know how to do it. I don't need to do it again. So let's open, click open. On my desktop, I've got this wing vector DXF. Okay, I downloaded this from the website earlier and placed it on the desktop. And you need to change this filter right here. The default is DWG, which is a AutoCAD drawing file, but we want DXF, which stands for Drawing Exchange Format. It's a standard text file. That is, you could open it with Notepad and read it if you wanted, and you could figure out what's in it. Okay, change the filter to DXF so that you can see this wing vector DXF in the menu. It's the list here. Then click open, and it does this. Okay, this is just floating in space with no units or anything. So, whoa, sorry, it's getting a little. So, select all this stuff. Do Control C. Go to Drawing 2, which you've opened with a template, right? So that you have the border and the units and the grid and all of that good stuff, and paste it in there with Control V. Drop that guy right there. Then do this. Start anywhere you want, but pick the line and the arrow. It's a little bit hard to see when you get the arrow, but I like to do it like this. Draw a box around the arrow, then click the line. Type move, or M for move, enter. With endpoint snap, okay, snap to the end of the line and move it by snapping to the end of the tail. That is the end of some other vector, just like that. One more time. See if I can grab both of these at the same time. Yeah. Then M for move, grab that guy, put it there, and just keep going like that. Okay? When you've moved all of these guys, just to be real quick, it should be some kind of, whoa, it should be some kind of, do it right, but just to save time, I'm going to be something like, it's going to be something like that, and then the resultant is going to be from here to here, and you could, to be clear, you could You could make it red and you could heavy it in. Okay, and then label it. Do it right, but do the rest of these vectors, right? Do them all. But I'm just trying to show you what the answer is going to look like. It's going to look like something like that. And then over here in the properties window, you should see the length 1.0 and 71. You should. And then label that. Stick a label on this thing. Okay, that's the assignment. I think that's it. 5 drawings. All right. Whoa. Assemble these, capture them all, assemble them into a PDF, and email it to me. All right. See you next time.